Hello, Palatine chemistry students. We are here talking about molarity today. What is it, and how do we calculate for it, and what other information can we gather from molarity? So first off, when we talk about molarity, we kind of have to go all the way back to states of matter. We can talk about solids and liquids. Um, and in these situations, we can talk about three main things. We can talk about solutes, solvents, and solutions. Okay, so basically all we're talking about is dissolving something. If you've ever made Kool-Aid or iced tea, anything like that, you've dissolved things. You've dissolved the Kool-Aid powder in water. Okay, now I don't know about you, but when I look at my Kool-Aid, I'm looking for it to be nice and dark. Okay, I don't want Kool-Aid that looks like this. It's not going to be very flavorful. The term that you have probably used in your life is that this Kool-Aid is much more concentrated, okay? All we're talking about when we're talking about molarity is we're talking about concentration. We can look at these words, they're synonymous to each other when we talk about concentration and molarity. And again, if we just quickly go through and talk about the three S's, solute, okay, that is the substance that's being dissolved. Okay, so if again, this would be like the Kool-Aid powder, or if it's salt water, it would be the salt itself. Um, the solvent is what's doing the dissolving, so that would be the water. Okay, and then the solution is the Kool-Aid that you can actually drink. All right, so here's some pictures of that. We have solvent, solute, and then once we mix them together, there's my solution. Okay. Um, I can go to a point called saturation point, and that's the most amount of solute that I can get into a solution. Now, there is a supersaturated solution, which I'm not going to get into today. But as we make our way down and we talk about molarity, again, we can look at this a couple ways. We could just say concentration is the same as molarity. Now, to put some either units of measurement or numbers to it, molarity is simply how many moles of the solute are in a liter. Okay, so how much Kool-Aid powder am I putting into that pitcher? Okay, how much stuff am I putting in the water? All right, and then we actually use the unit of measurement as a capital M when we talk about molarity. Okay, so this idea right here that concentration is molarity, we shouldn't go any further until we're all on the same page that simply concentration is molarity. What is concentration? Again, if I want to make strong Kool-Aid, I put a lot more Kool-Aid powder into it or less water into it. Okay, there's a couple ways I can make it more concentrated. Add more solute or add less solvent. Okay, so now that we have the general idea of what molarity is, now we can get into kind of solving for it. So again, we've talked about this, moles over liters. When we look at the molarity, what does it actually mean? So if I attach, these are the same pictures I was looking at before, but now if I attach numbers to them, very simple. The higher the molarity, the larger the number, the more concentrated it is. So this is a 1 molar solution. This is a 0.001 molar solution. Well, I'm not used to the word molarity, Mr. Skony. Could you help me out? Sure, I can. All we're looking at here is if I have a if I have a 0.001 molar solution, all that simply means is that I have 0.001 moles in 1 liter. To make it simpler, if I wanted a 1 molar solution, I would put 1 mole of something into 1 liter. Now, if you're asking yourself, I don't know what a mole is, you have to go back a couple lectures. One of the first lectures of this unit, and it'll discuss with you what a mole actually is. And a mole is just simply a unit of measurement. As we remember, like a dozen is 12, or a gross is 144. a mole is 6 times 10 to the 23rd. Okay, so let's then skip forward and look at how to do some of these problems. So these are the homework problems that are attached to this unit. And I'm just going to go through some of them. I'm going to walk through some of them. I'm going to be utilizing the mole map. This usually is one of the more tricky aspects of this unit, and hopefully we can clarify it today and clear up any questions you may have. So this first question says, how many moles of NaCl are in 5 liters of a 0.01 molar solution? Okay, so you may or may not have been introduced to the mole map by now. I will be using the mole map because I think it gives a very good visual representation of what we're looking at. Let's just look at numbers, okay? The numbers we have 5 liters and 0.01 big M. Now, 5 liters. We have this right here. All right, and I'll add the 5 in here. 5. We also have 0.001 molar. Well, that is right here. Okay, 0.001 molar. Notice that is not in a box, for lack of a better term. And these are the boxes I'm talking about. Okay, it's not in a box. You can't start or finish unless it's in a box on the mole map. Well, we have one thing that's in a box right here. And the question is asking for how many moles. So this is where we're going. So we're starting here and we're ending here. Now again, we have this information, but it doesn't do us any good in terms of start or stop. Okay. Now, if you wanted to, you can lay out all of the equalities you're going to use. And that equality is right here. So let's piece all of this together. Now that I know that I'm going to be starting at liters and going to moles using this equation. And let me clear all that up because this is the most important part, is that is the equation we're going to be using. X moles equals 1 liter. And where do I get the X from? I get the X from my molarity. Okay, I come back over here. Let's clean this up. Let's get a fresh look at it. What do I know I have? I know I have 5 liters of NaCl, and I put a little placeholder 1. Now, if I was to lay out, again, I have X mole, so 0.001, oh, I'll clean that up, sorry guys, 0.001 moles equals 1 liter. And that's where I'm getting that from this right there. Okay. Well, now I can utilize this, and I'll actually just take this and I'll say, okay, well, 1 liter, I have 2 options, top or bottom, because I can flip this, okay, it can go either way. So I can flip it, it can go either way. Since I have liters up here, I'm going to put liters down here. I need to cancel that out. I'm going to take my 0.001 moles and I'm going to put that up top. I'm solving for moles. If I was to cancel my units, I've just canceled liters. I'm left with moles. So then across the top, mathematically, it would be 5 times 0.001, all of that, divided by 1, so obviously not the most difficult math in the world. And I'm going to end up with 0.05 moles of NaCl. Okay. Factor label problem, like everything else we've been doing, the tripping point usually is the start and stop. Let's look at C. Similar type question. This one is asking for how many liters, and it tells me I have needed to dissolve 3 moles and a 6 molar solution. Okay, so I want liters, and now I got to decide where am I starting. Well, I can go back to my mole map. Let me clean up my mole map here. Again, it wants liters. So this is going to be my stop. That's where I'm going. That's my finish. Where am I starting? Well, my two options are either 3 moles or 6 molar. M, moles, molecules are all different. You got to pay attention. I know there's lots of M's. We're going to be all right. Again, you can only start or stop in a box. Well, I have to start there. I have 3 moles. Now, granted, I do have a 6 molar solution, but all I'm going to use that for is for my equality to get from moles to liters, because here's where I'll start. And I would recommend write on your mole map like this. Use it, okay? Mark it up. So I know that I'm starting here, I'm going here, and I'm using this one equality. So back this out, clean it up, starting with 3 moles, placeholder. I'm going to cancel moles. I'm going to go to liters. The equation I'm going to use, I derive from this. 6 moles equals 1 liter. So it's 1 liter, 6 moles. And again, all I did, I just took, I don't want the equation, I just took this, 1, and I took this, 6, and I just made sure that I canceled this unit. Okay? So then 3 divided by 6 gives me 0.5 liters, and there's my answer. And again, pause, start, stop, rewind. Hopefully that helps you walk through it. Let's move on. Oh, I had a little bit of work here already. Now we're going to look at this question. How many grams, that's what I want, very ugly color, I'm going to switch it. How many grams are dissolved in 1 liter of a 1.5 molar solution of Ki? So where are you starting? Where are you stopping? Let's go to our mole map. Let's clean up our mole map. Where am I stopping? I'm stopping on grams. So I'm going to back this out. I'm staying on one side of my mole map. We'll go to the other side later in this unit. I'm going to grams. That's where I'm stopping. I know I have 3 liters. That's one thing I have. I also have a 0.15 molar. 0.15 molar, which means 0.15 moles over 1 liter. I can only start and stop in boxes, so I'm going to start here. I'm going to go here using this equation, and then I'm going to go here using this equation. This has been touched on in another lecture. If you're unsure on how to find molar masses, that's definitely something you're going to have to go back and look at. I'll do it quickly in here, but I won't spend a whole lot of time on that section. Okay. So back to here. Clean it up. Where am I starting? I'm starting in 3 liters, placeholder. The equations I'm using, 0.15 moles, 1 liter. And I'm also going to use grams in 1 mole. This is going to be my molar mass of Ki. To get real quick review, need my periodic table, sorry. Potassium is 39.1 and 126.9. Okay, so that gives me, if I add that up, I get a total of like 166. So I'll head back here. And again, if you are unsure of what I just did, go back to the molar mass lecture and take a look at that. So this is 166, that's the molar mass of Ki. All right, so I'll go through. I kind of like using this method, so I know that I'm using everything. So I need to cancel liters, and the only place I have liters is right here. So I'm going to take my liters and I'm going to cancel it. I have to take its, oh, I don't want to take that. I have to take its partner with, and he goes on top. I put another equality. I have to cancel moles now. So I take the 1 mole. I have to take its partner with them. Goes here. So then I've got liters canceling, moles canceling. I'm left with grams, which is what I want. I would set it up like this in my calculator. 3 times 1.5 times 166, close parentheses, and divided by 1. So obviously, I think you can handle that. And you would end up with 74, about 74.7 grams. So another extra step on that is considered a more difficult problem. But again, we're just utilizing our equalities and our mole map. Okay. Last one we'll go through for the day. This one wants how many liters. It gives me 0.5 grams and it gives me 1.5 molar. Go back to my mole map. If you haven't noticed a pattern yet, you might want to rewatch the video every time. We're just going to the mole map. Where are we starting? Where are we stopping? Laying out our equalities gets us there every time. This is what I want. Okay, this is where I'm stopping. And how do I know that? Because it says how many liters. So that's what I want. It gives me grams. It gives me molarity. Well, all molarity does for me, this is 1.5, 1.5. And then the other thing it gives us is grams, so we're way over here. And this is 5.0 grams. So we are going to go across this way, utilizing that, and down this way, utilizing that. So I lay out all my information. I have, let's do this, the molar mass. So the molar mass of this would be 84. And again, if you need to know how to do molar masses, go back a couple lectures and you will see that included. So the molar mass of that is like one, oh no, I put 84, I didn't mean to put 84. 171.3 grams equals 1 mole. And then this equality gives me 1.5 moles, 1 liter. So now I have all my equalities laid out, and I know with what I'm starting with is 5 grams. I'm going to use, again, I'm going to use this method. I'm going to take the only place that I have grams, I'm going to put it there. It has to take its partner with them. It goes there. Let's cancel that moles unit. And let's cancel, or let's bring its partner with for the liters unit. I plug that into my calculator and I would get 0.0194 liters. Okay, so in review, what are we talking about? We're talking about concentration. We are talking about how much solid has been dissolved in a liquid. The solid is the solute. The substance doing the dissolving is the solvent. The combination of the two is solution. The more concentrated the solution has the higher molarity. Okay, we simply, if it is a 1 molar solution, it is 1 mole per 1 liter. And then we went through a couple sample problems on how to utilize our mole map, walk through using our equalities, canceling units using the factor label method. Hope this helps. Go